Thank you very much for the opportunity to speak here tonight. Longtime New Hampshire resident, longtime serial entrepreneur. This is my 9th technology company over the course of the last 25 years. And I have to say that this is one of the most disruptive, transformative opportunities of any of the companies I've been involved in. As she read the introduction to what Plexxi is all about, we talked about legacy infrastructure. I hate to admit it, but I was actually part of building the legacy infrastructure I'm about to replace. So let's take a look at Plexxi. Let's see here. All right, so we're based down in Nashua, New Hampshire. You may or may not recognize this building, but 30 years ago, that building housed the most powerful technology company in the country, a company called Digital Equipment Corporation. Unfortunately, like happens to many technology companies, they didn't evolve. They did not evolve. They did not transform. And ultimately, they got replaced. Along comes a little startup that I happen to be a part of called Cabletron Systems. We come along, we buy the assets of DEC. And along goes that company. We raised about $1.5 billion in revenue, building a great success story. But that same infrastructure that we built, that legacy infrastructure that we just talked about, is the same infrastructure that still exists today, literally 25 years later. Think about the highways that you came in on, the old decaying bridges. That infrastructure can't support where the world's headed. So what are we trying to do? We're trying to refill these hallways, build this back into the greatest company here in New England, the greatest new tech company in New Hampshire. So how do we do that? Let's take a look at setting the stage of the market. We're involved in the build out of the next generation data center. In the old days, if you look to the left side, you think about data centers and how they were set up by storage, compute, and networks, and the applications that sat on top of them. Nice and organized, nice and neat. But then along comes something called virtualization. And suddenly that data, that information, seems to be everywhere. It's shared. It's around the world. See the network architecture underneath? It's the same network architecture that we invented back in the late 80s. It still exists today under both of those scenarios. And along comes the next thing some of our other panelists have talked about tonight. And along comes the cloud. Now look at, we've got all these SaaS applications. We've got tremendous amounts of data that are being created by all these different types of devices. Things called the Internet of Things, mobile devices, platforms, laptops, you name it. They're creating more and more data. Clouds, capturing all this data. Ultimately, this is all great stuff for business and efficiency, but the plumbing never changed underneath. It's still the same network infrastructure. And as you can see, data applications are everywhere. So the innovation's starting to come underneath. But over to the far right, you can see it's still the same architecture. So what happened? About 5 years ago, we started working on a technology that a little company called Google said, hey, you know what, this network infrastructure, it can't support what we need to do in terms of search engines, in terms of all the data that comes in. So we'll invent our own. We'll go hire everybody out of Stanford and build our own software-defined network. We sat with them. We started talking about how they're doing it. We brought in some brilliant people from basically the New Hampshire and the Massachusetts education community. We started to do the same thing. We're bringing Google to the masses. We're building what Google did inside, we're building for the enterprise. So how are we doing that? Well, first of all, take a look at this. This is pretty remarkable statistics. And again, the panelists here, you know, we're all at fault for creating all this data. If you look at that, since the beginning of digital time, if you will, 4 zettabytes of information have amounted to date. In the next 5 years alone, 10 times that amount of data. How do you expect the infrastructure to uphold? You just keep building more and more networks. You have to build parallel networks to support all these applications because that network infrastructure gets too clogged too quickly. So let's take a look at the reality of the situation in terms of what happens at Google. In fact, I'll steal a slide from Google. This is the old network architecture. What happens is when the applications come in, only 40% of your network can now get utilized. You have to build a new network. Tremendous capital expense, tremendous operational expense to manage it. So what does your network look like? I don't know how many of you have ever been in a data center, but in the old world, it used to be kind of neat. In the new world, it's pretty ugly, okay? So just for example, this is a little bundle of cable we put together. This would represent 175 servers and applications, all right? You'll see a picture in a second what a real data center looks like. In the middle, you'll see a little red dot. That's Plexxi. That's what we do to a data center, just from the cable standpoint alone. So here's what a data center looks like today. Okay? That's the backside of those servers. You tell me how you're going to fix that network with all this data coming over those networks. Something has to change. So now Google built their own because the industry didn't keep pace. That's why the infrastructure has to change. Google achieves 95% utilization, not 40%. All right, so how do we do this? We focus on doing it two ways. We make it simple, we make it better. So what do? We collapse those network tiers. Those diagrams I showed you earlier, you saw stacks and stacks of switches. We collapse them into one single box. Come visit our box in the back. All those get collapsed, I'll show you in a second, in literally one corner of our box. Then we do it from a software standpoint. Think of us as a GPS, as a Waze, basically carving wider and wider lanes for applications dynamically by their own control, saying, I want to be here then. And what we do is we literally slice light waves into different colors and accommodate those applications per the width of those colors. All right, so here's how it works. See all the layers? You can see basically from that middle layer down, all those are represented boxes. And there's, it's obviously oversized, the Plexxi switch on the right side. So you take those layers and you collapse them, literally, right into that corner. It becomes the industry's first converged network switch. It becomes one layer. All of this becomes one cable, connecting one cable to one box. You'll see the CapEx and the OpEx savings in just a minute. So let's look at it from a software standpoint. What happens next? So probably many of you people come here and in the old days you would have come out and you print your directions, you get stuck on the highway and you say, okay, what do I do now? I'm in a traffic jam. You don't know about the parallel highway that's right next door that you can jump on. So what do? Well, nowadays you can go to your phone and your phone through Google Maps might help you, or more specifically, the best way nowadays is using Waze, right? Waze shows you all kinds of routes, different highways you can take. That's what we're doing for applications, for data. Choose the highway you want. The application does it dynamically, goes down the highway that gets you the fastest. So I'm going to show you a quick, one last. All those lines around the side on the right side, those colors, are literally fiber optics being cut per application. Instead of a static, if you will, stovepipe pouring an application into a static network switch, what we do is we take and we continue to slice light waves tens of thousands of ways until you get the time and the bandwidth you need to get the job done. Here's a different way of thinking about it.
It creeps along like a rolling centipede. If you blink while driving down the 15, you'll miss it. But if you slow down and focus, you'll see what Caltrans calls a barrier transfer machine. Normal people call it a zipper. It moves the concrete barrier dividing the express lanes one lane over.
That's what we do. We just do it for data. Data comes down the highway and it says that lane isn't big enough for me. Cut me a new lane. It does it dynamically. There's no more no more manual intervention there. So what does that mean? Look at these savings, right? 90% plus on the CapEx side. You saw it on the cable side. 95% plus on the OpEx side. Let me talk you through a couple of applications of customers. The first one on the far left. Yes? Okay. Really? Wow, that went quick. All right. Thank you. Thank you very much, folks.